combination, we are building our combination slowly, and each time we add another thing, we check the target. And if the total sum of this combination is the target, then we know that that's one of the combinations we want to add into our output. So let's start building this combination. We add 2 of it, and let's just keep going step by step here from left to right. Kind of a backtracking approach, and also like recursive type of approach. We'll keep going with 2 here until we reach sum of 8 is greater than 7. So we pop 2 out. That's backtracking, right? Now we add 3 in, still greater than 7. Pop it out, add 6 in, still greater than 7, and so on. So we have tried every single number from this candidate on this branch, I think. So we pop 2 out, right? Backtracking again, add 3 in. Now we found a solution because 2 plus 2 plus 3 is 7. So we add that into our output. And we go for 6, we pop 3 out, 6 in, up 7 in, greater than target. Now backtracking again, add 3 in. Now here's the interesting part. If we don't skip the values before the one we are currently at, which is on 3 here, like if we add 2s in, like a normal recursion type, right? This is a duplicate, right? See, the frequency of the numbers in this current combination is the same as the one we currently have in our output. 2 number 2, 1 number 3, 2 number 2, 1 number 3. So this one is a duplicate. So this will fail. That's why we want to skip. So we are add this current index of this recursive branch. We don't want to add the value before. So we're at 3, so we just go with 6. And now check again. So we're going to pop it out. And we get it. And once we finish with 3, we move on back to the branch. Now we don't want to add 2 again, right? Because we're following that 15 in real life, we don't use recursion in our software, right? So I'm just trying to use the stack now. It's essentially the same thing. Recursion is like keeping the state of the return objects. We'll say it's called return address and signatures and all that inside the stack, right? So essentially the same thing. So have a stack, return the state using a tuple because we are going to keep track of these 3 and this one right here. So this one can keep track of the current index. Where we at, right? Let's say we are at 3, we don't want to add 2 back in, right? So we're going to keep track of the index, so we can skip 2. And then current sum, because we want to check if that current sum is greater or equal to 7, so that we can know that we can add it to the output, or we can skip the next output, because we want to have the values that are there. It kind of makes sense with our function code. Vector integer, just the word combination, right? So we want to see how the function is target is to add this combination into it. And then you just top it out on stack. You can do this one line Python. I don't know why we have to top it first and pop in C++, but whatever. And now we're gonna check if the current sum is equal to target. If it's equal to target, what do? We add this combination into our output, right? Because the sum is the sum of this combination. This is what we are subtracting from. So we do output push back current combination, and then we are gonna explore the values starting from the starting text, right? So we did. We tried to go the algorithm in Excel. So we did. So size in here, and just put those values in. But before that, let's compute the new sum, which is gonna be the current sum plus the current candidates. Then we're gonna here, right? And then we check if the new sum is greater than target, and we skip this candidate. The reason why we're skipping is because let's say we are at 2, 2, 2. If we add 2's in, that'll be 8, 8 greater than 7, right? So we can skip it. We want to push it into our stack. So essentially we just add a skip operation. We can add it here also if we want to, I think. We add it here, but this is cleaner. You don't have to go through a while loop just to skip this candidate, right? And now, once we know that this candidate is the one we want, like the potential candidate, we push it into our stack. We just have to create a new combination. And this new combination is essentially the current combination. But with pushing back a current candidate, right? So this is essentially saying like if you are at if car is 2, 2, we create a new combination and pushing 3's in, and that will become a new combination. I think we can do it one line Python. Just have to slash it out and add value to the end. C++, and push everything in. So I'm pushing in the next, push on the start next one. Is I and current sum, all of that. I think that's just it. Yeah, so it's just a nice little code. Like I said, we loop at the start index and skip every single index before we start. That's why we try to out the start index. And current combination, building combination, each iteration, and once we reach the target, we push it back to the output. But if the new sum that we are trying to look at for this candidate is greater than target, and we just skip it. So those are the tricks I feel like worth noting. And yeah, this one can easily be done in a efficient approach. But I feel like stack is more, I'll say it's not even more efficient, just safer. I don't know, feel like